Hi everybody, it's Mrs. Hannaforth and I am going to be reviewing and doing a video on Lesson 12, the Cumulative Practice Problems. I'm doing this to make sure that we understood yesterday's lesson and to hopefully go slow enough and go through some of these problems to address any misconceptions or misunderstandings that you may have. So I'm trying out this video recorder in this direction. Hopefully it's going to minimize me writing over, but I'm going to do my best today. All right, so let's get started. So we've got here are some equations that define three exponential functions, f, g, and h. And basically what we are being asked to do is which of these functions grows the least quickly, which one grows the most quickly, explain how you know. So the very first thing I want to just review is what you learned yesterday on the Lesson 12 video, is that if I have functions exponential, that there are things that we should note right away. First of all, that these all have the same initial value of 100. So that means my equations or my graphs, when I graph them, are all going to start at the same spot. The other thing I'm going to note that each of these has got a different growth factor. When am I talking about that? The factor is what I'm multiplying by. So how quickly or how is my exponential function growing? This is growing by a factor of 3. This is growing by a factor of 3.5. And this is growing at a factor of 4. So if I just think about factors, if I multiply something by 4 versus multiply something by 3, what's going to give me more? Obviously, if I multiply by something by 4. And I can take that one step farther and say, okay, well, let's just double check. So if I start at 100 and I'm multiplying by a factor of 3, where would I be if x is equal to 1? So if x is equal to 1 in each one of these equations, I can easily do some calculations. 3 to the power of 1 is 3, and 3 times 100 is 300. And if I keep going, this is 3.5 to the power of 1, which is 3.5. And 3.5 times 100 is 350. And if I do the next one, 4 to the power of 1 is 4, and 4 times 100 is 400. So we can look at each one of these. If I start at 100 and go to 300, if I start at 100 and go to 350, if I start at 100 and go to 400, which one got the biggest quicker? Well, this one right here. Okay, so this one grew the quickest was h of x. Which one grew the slowest? Well, this one. I went from 100 to 300. So this was the slowest or the least quickest. This was f of x. Okay, and it says, explain how you know. Well, what I like to do is look at the growth factors. So the growth factor in h of x is 400. Oh, sorry, is 4, not 400. Whereas in f of x, it is 3. 4 is bigger than 3. Therefore, h of x grows faster. Okay, so that's your explanation, and I gave you a couple of different ways to look at it. Okay, so now what I want you to do is question number 2 asked us So we have equations. Now we're given a graph. And it's like, okay, so let's match the equations to the graph. So which graph corresponds to each function? So again, a couple of things I want to just point out to you real quick is take a look down here. They all start at the same place. So what I need to determine, and we all know that from our equations, they all start at the same place. So which one is showing that it's growing faster? Well, I want you to remember when we did the commentary on the radio or the swimming race, the one that was the steepest, the one that went up the quickest, the fastest, is the one that's growing the quickest. So if I look here, I can go, okay, I start here, and I've got A is at, if I look at this as being time, if this is 2.5, well, where's the value of A? The value of A is above 3,000. Where's the value of B? It's only a little bit above 2,000. Where's the value of C? It's way down here below 2,000. So I'm going, which one's faster or larger? A. So which one is F? Well, A is the one that's growing the fastest. So which one up here was growing the fastest? H of X. So H is A. Okay, so now let's look at B. B is right in the middle. Let's look at C. C is more flat. It's flatter than A. So this one is going to be my slowest. So going back up here, which one was growing the slowest? F of X. So C is the F. And the one right in the middle is B. It's 3.5. So G is B. Okay, so then it asks, so why do all of these graphs share the same intersection point with a vertical axis? Well, yesterday in the video, you were reminded that y is equal to ab to the x, and that the a is the initial value, b is the factor that we grow things by. So if I look back at my equations, these all have the same initial value. So why do all the graphs share the same intersection point? All equations or all the functions have the same initial value. And I'm going to reference the same A, which is equal to 100, according to my equations. All right, so now let's move on to question number 2. You've got, again, 3 graphs. They're showing right away. I'm going to note something that I'm noticing that K, L, and M. K is above L and M. But one of the other things I want to point out is, look at this right here. They all have a different initial value. So these are all different. So I haven't even looked down here at my question. I'm just noting something on the graph. So the very first thing I'm going to notice that one starts at 100. This one, if I look at this is 0 and that's 100, this looks like it's about 50. And it looks like I'm halfway between 50 and 0, which I'm going to say looks like to be about 25. That's just, again, I haven't looked at this. I'm just looking at the graph. All right, so now it says we're supposed to match each equation with the graph. So again, I'm going to take a look, and I'm going to see that I've got y is equal to 20 times 2 to the x, 50 times 2 to the x, 100 times 2 to the x. All right, well, therein lies, I'm going to note some things. They all have different initial values, which is what I pointed out on the graph. The other thing I want to make note of is the fact that, look at this. They all have the same growth factor. So they're all growing at the same rate. They just start at different points. So now let's go back and figure out K starts at 100. So K starts at 100, so I'm looking at this one right here. Then I'm going to change colors, and I'm going to know that this one started at 50, so L starts at 50. So I'm going to go right here. And the last one, this one started at 20. And I know that it's because it's halfway between 50 and 0. So this one goes with M. Okay. So again, on this page, we dealt with looking at different growth factors, same initial. We looked at a graph with regards to that. And then we came down here and we noted that now I've got different initial values, but my growth factors are all the same. So taking a look at the way those graphs look. Okay, moving on the next page, it asked us to do a graph. And so I'm looking at that and I'm like, okay, well, I'm given a graph. And I note that this right here corresponds to that equation. So one of the things I want to point out is take a look. There's my initial value right there. And I can actually note each point corresponds to the growth of this equation. So I could easily go, this is 1, 200. This is 2, 400. This is 3, 800. A couple of things I want to point out. Take a look. When I go from 200 to 400, what did I do? I multiplied by 2 on the y, so 200 went to 400, and that same pattern should continue up here. Multiply by 2 again. 400 times 2 is 800. How do I know that that's going to work? Take a look at my growth factor right there. There it is. This is the growth factor. I'm multiplying by 2. In other words, I'm doubling. All right, so noting that it's asking me to now sketch a graph. So I've got y is equal to 50 times 2 to the x. And then I've also got a graph of y is equal to 200 times 2 to the x. One of the things I'm going to note is that growth factor is the same. So that means it's growing at the same rate. The only thing that's different is where I'm starting my graph at. So what I'm going to do is I'm going to create a table just again to review. If, again, you understand this, you could easily skip, but I think it's important. So I'm going to label my two tables of x and y. I'm also going to start with the first one, y is equal to 50 times 2 to the x. So I'm going to note that if I use an exponent, there's the x right there. I'm going to put values in for x. So what values am I going to use? 0 and 1, because I'm looking at my graph. I only have 1, 2, and 3. I could actually put 4 and 2 if I wanted to. So I'm going to go ahead and do that. So I'm going to go ahead and use 0, 1, 2, 3, and 4. And I'm going to show you the math behind it just to kind of give you a review. So I'm going to go 50 times 2 to the power of 0. We all know that 2 to the power of 0 is 1. So 50 times 1 is equal to 50, which again, I can get directly from my equation. That's my initial value. So I'm going to go ahead and graph that. So I'm going to use green. So 0, 50 is about right there. And I'm going to continue to use 1. So I'm going to go 50 times 2 to the power of 1. 2 to the power of 1 is 2. And 2 times 50 is 100. And again, using my doubling or multiplying by 2, I could easily go 50 times 2 is 100. So my next point is going to be 1 and 100. So I'm going to go right there. And I can continue this pattern by multiplying by 2, which means I can get to 200. Or I can come down here and go 50 times 2 to the power of 2. 2 to the power of 2 is 2 times 2, which is 4. And 50 times 4 is 200, which is what I've got right there. I can continue and go 50 times 2 to the power of 3. I know 2 to the power of 3 is 2 times 2 times 2, which is 8. So 50 times 8 is 400, which to go up here, and I can easily do that as well and multiply this by 2. 200 times 2 is 400. So again, I can go over here now and graph 3 and 400, which is right there. And then the last one would be 4. I can multiply that by 2, which means I'm going to get to 800. Or I can come down here and go 50 times 2 to the power of 4. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 2 times 2 is 4, and 4 again, which is 16. So 50 times 16 is 800. So 4 and 800 goes way up here. So now I'm ready to graph, connect my points. There it is right there. Okay, and I'm going to do the exact same thing for 200 times 2 to the x. And I am going to put in 0 and 1 and 2. I think those are the only points I can use because my graph isn't large enough. So again, if I put in 0 right there, 2 to the power of 0 is 1, and 1 times 200 is 200. Or I could easily have gotten that from the equation. So 0 and 200 means my point's going to be right there. Okay, and I'm going to continue. I can multiply by 2, which means this is going to be 400. Or I could go in and put this as being 1. 2 to the power of 1 is 2. 2 times 200 is 400. So 2 and 400, let's see. I got 0 and 200. I got 1 and 400 right there. And I think I can fit 2. So 2 and 800. All I did was multiply that by 2. Or I can go up here and put 2 in. 2 to the power of 2 is 4. 4 times 200 is 800. So 2 and 800 right here. And now I'm going to connect. And you can see 3 different graphs, all growing at the same rate. What's different about them? My starting or my initial value. Hope you found that video helpful. Again, just taking our time going through this, and I will post the video to help you out.